In this video, we're going to look at solving and evaluating functions. So here's where we get to see function notation really be useful to us. Okay, so in the table below, this is giving some values for q equals g of n. And we saw this earlier. And it is a function. Okay, this does have to be a function. In this case, they're asking us to find g of 3 or evaluate g of 3. So really what we're trying to do, because we're talking about functions, is we're trying to pair up each input with its output. So in part A here, they're giving me the input of 3, right? Because it's where the n is. So I'm going to look at the n row here and I'm like, boom, there's 3. And 3, it's paired up with 7. That's its output. So g of 3 equals 7. That's how I'd write this ordered pair that's represented right here. G of 3 equals 7. All right. Now this one's a little different. This one is giving me not the input, but the output. They're telling me it equals 6. And they're saying, so what's the input for that? So that changes it. That means then I have to look no longer at the ends, but at Q. Okay. So actually, I see 6. Oops, sorry, I thought it was the highlighter. I see 6 twice. 6 is matched with 2 and 4. So I can list 2 answers. That's fine. Oops. N equals 2 and N equals 4. Those are the 2 values that give me 6 as an output. And there's nothing wrong with that. It is, in fact, a function. Okay, let's look at another example. So now let's use a graph to do the same kind of game. This time, we're looking at this graph. You might recognize this graph. You might even know the name of it. It's called a parabola. We'll talk more about that soon. But in this graph, they are asking me to evaluate f of 2. So they're giving me the input of 2, and they want me to find the output at that value. So in this case, x is the horizontal axis, y is the vertical axis. So these are all of these values right here. Okay, so I'm going to take a peek then and find the x value of 2. And that's boop, right there. So I'm going to this x value and I'm like, okay, so in the graph, that corresponds to a y value of 1 or of 1. And there we go. Let's try it in reverse. So this time they're giving us the output value. So here, let me erase all the stuff I just drew over here. So now we're told 4 is the output. And we're being asked to figure out the input. So now we're looking at these values this time, the y values. So 4 is right here. And in that case, it actually matches up with this and this. 2 different input values. So it matches with -1 and +3. All right. Now, let's look at formulas as functions. So this is actually giving us a formula, and still we're looking to evaluate versus solve. So in part A, when they ask us to evaluate k of 2, that means they want us to plug 2 in for t in this formula. So k of 2 equals, okay, so plugging it in to this formula up here, right? This formula right there, in for t. That means that I'm going to get 2 cubed, which is 8, plus 2, which is 10. Boom. There we go. That's k of 2. So part B says, solve when k of t equals 1. So this is different. They're taking k of t and they're setting it equal to 1. Well, they're trying to figure out what t value gives us 1. So the way we figure that out is we actually take the equation and set it equal to 1. We're going to figure out when this equation is going to spit out a 1. So I got to solve this equation. Let's do that. Subtracting 2 from both sides will give me t cubed equals -1. That's not a problem because I can take the cube root of both sides, and a cube root of a negative is not an issue. That ends up being -1 because -1 cubed is -1. All right, let's try another one. This one is using h, and we have p as our input in this one. So h is our output. I'm sorry, yeah, h is our output. Well, they don't really say that, do they? H is the function, p is the input. Okay, so let's go ahead and try to find h of 4. That means we're going to plug 4 in everywhere we see p. So since p occurs twice, 4 is going to occur twice. So this is 2 times 4. All right, so 4 squared is 16. 2 times 4 is 8. That comes out to 24. Okay, but the other one is trying to figure out which p value do we have to plug in so that we get 3. So this time I'm taking p squared plus 2p, and I'm going to try to figure out when it equals 3. What p value gives me 3. Okay, so to solve this is a flashback to intermediate algebra. We're going to need to get it equal to 0 because it is a quadratic. And really the 2 options most people will do is either factor or use the quadratic formula. I'm going to go ahead and factor this. This factors into p plus 3 times p minus 1. And that's going to be p equals 3 and p equals 1. So 2 different values, if I plug them in, I'm going to end up getting 3 coming out of that value. All right, now this one is actually saying we want to write this as a function. We want to take this existing equation here and write it in function notation. So here's how we would do that. Since they're saying p equals f of n, we use p as our kind of hint here. We want to get p by itself. We want to isolate p on one side. So I'm going to try to get that by itself. Okay, so to do that, I'm going to go ahead and minus 2n. So I have 6p equals 12 minus 2n. Then I'm going to divide everything by 6. I'm going to do that individually. So p equals 2 minus, and that would be 1/3 n, or n over 3. But I want to write it as function notation. So as a function, then I would say f of n equals 2 minus n over 3. I did say, by the way, that n over 3 could have been written as 1/3, just so you know. They're the same statement. Okay. So there we go. Now let's try it differently. Different equation, same idea, same concept. So in this case, y equals a function of x. So we're trying to isolate the y. That's the one we're going to try to get by itself. So I'm going to work on getting this by itself. Highlighter. All right. So I'm going to subtract x squared from both sides. So I'm left with y squared equals 1 minus x squared. Okay, now I'm going to take the square root of both sides, which that's totally acceptable. However, and you might remember this again from intermediate algebra, that when you take the square root of both sides of an equation, you actually have to introduce a plus or minus. And that's actually going to be a problem. The plus or minus is saying that if I put in one x value, I plug in something for x, an input, I'm going to actually get 2 outputs. That's no longer a function. So this is not a function. So it doesn't make sense to write it in function notation because it's not a function. And that would kind of violate function notation since it's not a function. So that's kind of a way of being able to tell if an equation is going to give us a function or not. If somehow we're going to end up with two output values, like in a case like this where we take a square root or any even root, in fact, we'll always end up with a plus or minus, giving us two output values.